T109 Algorithms and Programming. Okay, so in this set of videos what we're going to be looking at is the difference between the stack and a queue in a computer program, and how when you run a computer program you have to be careful you understand how these work so you can look and see which variable is going to store which value when you run your program. So let's have a look at the question. When the procedure shown is executed in list order, what is stored in the variable z? So here we've got our procedure and we're going to execute it in list order, so down the list like this, and what we want to do is see what we have in our variable z from this final pop command. So here the stack and the queue structures are initially empty and 4 types of operation are defined as shown below. So we've got our 4 different types of operation used in our program here. So first of all we've got our push y, and that's going to put the value of y into the stack. We've also got our pop, which is going to retrieve the value from the stack, and we'll look at how the stack works so we can see how these commands work. Finally we've got enq, which is going to put the y value into the queue, and we've got deq, which is going to retrieve the value from the queue at the end. So what is our value of z going to be? Is going to be 1, 2, 3 or 4. So as we said, to understand our push and pop commands we need to understand how the stacks work, and they're commonly known as LIFO structures, which stands for last in, first out. This is different to a queue, so we have to look into how this is going to work. With computer stacks, putting something on the top of the stack is called a push. When you take something off the stack, it's called a pop. It's kind of very similar to having a stack of plates, in the sense that if we had our plates down here, we would add 1 plate to the pile, then we would add 2 plates to the pile, and this is called pushing to the stack. So we're going to push another plate to the stack. If we want to take off the stack, we can only take off the top, because taking something off the bottom, we're on the floor there, so we can't take it off. So if we want to use our pop command, we have to take it off the top. So this is how a last in, first out, or a LIFO structure works. And here we can see this illustration with numbers. So we push 10 on, we then push 20 on, we then push 30 on. So this is working how we would expect. However, when we take the values off, when we use our pop command, we take off the last value we put in. So our last in is our first out. Then we use the pop command again, we take our 20 out, and then we use the pop command one more time and we take our 10 out. So now let's look at the concept of a queue, and we've looked at these before. So it's a first in, first out structure, similar to a queue at, say, a shop or at a theme park, where if you're the first one in the queue, you're the first one out the queue. A queue has 2 ends called the front and the rear of the queue. Items are always added at the queue at the rear and removed from the queue at the front. The operation of adding and removing the items is called enq, nq, and deq, deq. And here we can just see an illustrated version of what that looks like. So we have our values coming in at the back, and we've got our values being taken away at the front. So we've got our nq and our deq. So let's look at how the stack and queue look when our program is executed. So the first instruction we had was the nq1. So we add nq, we add 1 to the back of the queue. The next command we had was nq2, in which case we added 2 to the next spot in the queue. The next command we had was the push3. Now the push3 pushes 3 onto the stack, and if you remember, we have a last in, first out system in the stack. So then what we do is we push the deq. So first of all what we have to do is run this deq command, because this is like a command within inside a command. So first of all the deq gives us a value which is our last value, our first value in the queue, which was this 1 here if you remember. So the 1 is then going to be pushed onto the stack. So if we just highlight all of this now, this whole command is going to push the value in deq, which was originally a 1, into the stack. Next we use our next command, which is going to be nq4, which is going to add a 4 to the back of our queue. Then we're going to run the same command as we did here, the push deq. So we're going to run our deq, which is going to take our value from here, and then we're going to run our push command. So our push command is going to simply push the value that was stored in here onto our stack. Finally, we want to see what our value of y is. So we have to run this final command here, which is y equals pop. Pop means we take the last value that was put into our stack. This is because it's a LIFO structure, so we can only access the last inputted value. This means that our final outcome is going to be that y is equal to 2. So we can just double check this with the answer on the next slide. And what we can see is that we have the correct answer. Our answer is B, that the output is equal to 2. So what have we learned in this video? We've learned how our programming languages, if they run sequentially, how they're going to access both queues and stacks and the differences between these.